In this video, I will take you through selection sort. We will examine the code, what it means, what it does. I will then go through an example of selection sort, and then right at the end, I will go over the code again and draw some comparisons between this algorithm and previous algorithms like bubble sort. Selection sort has the same number of comparisons that bubble sort has. Because it has to compare everything in the list, the numbers of passes are going to be the same because it has to go through the list the same amount of times. But the numbers of swaps is decreased because it just makes one swap every pass rather than making a number of swaps every pass. Its complexity is still n squared, although it does run a little bit more efficient than bubble sort. So if we have a look at the code, the first line is still quite familiar because it's going to run through the list n-1 times. This means that the list is going to shorten each time it runs through. The big difference here is that it has a maximum value. So there's a variable which holds the maximum value. Now this variable starts at 0, so this will be element 0 in the list, and will return to 0 each time it starts a new pass. In the second for loop, which is nested in the first, location in range steps through the list. It starts at 1 because it's not going to check 0 against 0. It's going to check what's ever in 0 against whatever is in element 1. The fill slot is going to be the last position in the list. The if condition makes the comparison and then runs the code if the conditions of the comparison are met. The final piece of code is where the swap takes place. Once the algorithm gets started, you'll realize there are two portions to the list. There will be the sorted portion at the end, which increases by 1 each time, and there will be the unsorted portion at the beginning, which decreases by 1 each time. Now let's have a look at the example, and then I will go over the sorting algorithm again at the end. Our algorithm takes into account the length of the list and will decrease by 1 each time. So first of all, it will check all of them, and then it will check to here, and then it will check to this one, and then it will check to this one, and then this one until there's just this one left. The first slot, which is 0, this is going to be the maximum. This will be the location, and the location will increase by 1, and comparisons will be made. 3 is the maximum, and it is compared to 16. 16 is greater than 3, so 16 becomes the new maximum. We move up 1. 10 is compared to 16. 16 is greater than 10, so 16 stays as the maximum. We then move up 1. 1 is compared to 16. 16 is greater than 1, so 16 stays as the maximum. We then move up 1. 45 is compared to 16. 45 is greater than 16, so 45 becomes the new maximum. We then move up 1 and compare 23 to 45. 23 is in the fill slot. 45 is the highest value, so these swap. We then reset and go through the loop a second time. So now n-2 is the length of the list. 3 is in position 0, so 3 is the maximum value. 16 is compared to 3. 16 is greater than 3, so 16 is the new maximum. 10 is compared to 16. 16 is greater than 10, so 16 stays as the maximum. 1 is less than 16, so 16 stays as the new maximum, and we move up 1. 23 is greater than 16, so 23 becomes the new maximum. 23 is already in the fill slot, so it stays where it is. Our algorithm didn't know that 23 was in the right place when it started. The only thing it can do is to check. Now we go back, and the maximum value is reset to 0. Location is reset to position 1. 3 is checked against 16. 16 is greater than 3, so 16 is the new maximum. 10 is compared to 16. 16 is greater than 10, so 16 stays as the maximum. 1 is compared to 16. 16 is greater than 1. 1 is in the fill slot. 16 is the greatest value, so they swap. The maximum value is reset to position 0 and location reset to position 1, and we start again. 3 is the maximum. It is compared with 1. 3 is greater than 1, so 3 stays as the maximum. 10 is then compared to 3. 10 is greater than 3, so it becomes the new maximum. 10 is also in the fill slot, so it stays where it is. And we reset again, and the new maximum is 0. Position 0, which is at 3. And the new location is 1, which happens to have 1 in. 3 is then compared to 1. 3 is the maximum. 1 is in the fill slot. 1 and 3 then swap, and our algorithm is complete. So let's run over this code again. The comparisons is the same as the comparisons in bubble sort and short bubble sort. Just here, we don't need to make as many swaps. We pass through the list the same number of times, but the worst case scenario for the numbers of swaps is going to be 1 less than the length of the list. So if we have a list of numbers, we start off with, if I write the elements up here, these are the indexes. So if I put that in indexes, and these are the elements that are in the list. As we go through the list, we end up with a sorted portion. So 2 here is going to be in the maximum value because it's the only one that's been looked at so far. And then the next loop runs and checks against 2. Since 10 is greater than 2, 10, its index then becomes the maximum value. So this then becomes the maximum value. And that keeps on going through the list, and then eventually this one will be the maximum value. This guy on the end here is in the fill slot. So this is going to be the fill slot, and the fill slot will decrease by 1 each time. So if we were to write the list out again, we would have we would have something like this, where if I draw this line in here, this is now the sorted portion of the list. When we run when the loop runs again and we do n minus 2, because this one would be n minus 1, this guy here is going to be the maximum value again. So that's why it's set back to 0, element 0, or index 0, I'm sorry, with the element 2 in. As we go through the list, 10 will be seen as the one that is the highest, and that will end up in the sorted portion of the list. And the sorted portion of the list then moves down, 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 until there's nothing else to sort. So if I take that out.
It's 1 o'clock.
Okay, so if we were to write that list out again, we would have to so now this, all of this becomes the sorted portion. And then we would move on to n minus 3. Hopefully now you get the picture there. So it just makes one swap, whereas bubble sort will make this many swaps. And so will short bubble sort in a worst case scenario. Although selection sort is still in the order of n squared, because it's not making so many swaps, and these exchanges are costly in resources, it does run a little bit faster. But for large values, you can imagine how n is going to increase very fast. It's going to go like that, where it soon, let's make these resources, it soon slows right down and its performance is not very good. We use this big O notation, it's called big O, to make comparisons between algorithms, because obviously using a stopwatch just is not satisfactory for testing algorithms. If we go back to our example here, so let's just make this a little clearer. This goes over here. This is when it's N2. This is when it's N3. This guy here is now in the field slot. This is the field slot. We go back to this one being the maximum value. And then we work our way through the list. So 2 will be in the maximum value. That's compared to 4. 4 is greater, so that's in the maximum value. It's compared to 1. 1 is less, so 4 stays in the maximum value. And we end up with 8, that going into the maximum value, and 8 then being compared, because 8 is in the maximum value, and it's the maximum value that's always being compared to the next one. We end up with 9. So 9 is already in the field, in the field slot. So it just stays where it is. So no swap actually happens there. So each time we go through the list, we potentially have the opportunity to make a swap every time we pass through the list. So the maximum amount of swaps is going to be n minus 1, but in this case we don't need to make a swap there, and it's going to be the same on the next level. So we have 2, 4, 1, 8. Oh, that should be a 9. So the only difference is that the sorted portion, all of this, is now the sorted portion. Let's make sure we've understood this correctly. We go through the list, and this guy here goes into the value of max value, and its location is stored, and its location is 0, index 0. That's what I mean by location. This guy here is going to be the fill slot. Now what happens as we go through this list, the comparison that's being made here is the comparison between this guy and this one. Is this guy greater than 2? And the answer is yes. So this value is now stored into our max value variable, and its location, its index is stored, and its index is at 1. Then we make the comparison of this guy and this guy. This one is 0, so 10 stays in the max value. Then we move on to 8. 8 is less, so 10 stays in the max value. Then we move on to 9. 9 is less, so 10 stays in the max value. Then we move on to 4. 4 is less than 10, so 10 stays in the max value. And the only thing left to do now is to check what is in the fill slot, and the fill slot is greater than 10. So this changes to what the higher value is, and its value is stored. Now that there becomes, let's change that, becomes 6. The only thing left to do is now do the swap. Well, it's already in the right place, so it's left alone. So we move on. This becomes the sorted portion. And we look at the values in it again, and 2 again becomes the maximum value. Max value. Comparisons are then made again. We can see that the 10 goes into there, and its location is also stored. And then we look at this value here. This value is less, so 10 stays in the max value. This 8 is less, so 10 stays in the max value. This value here, 9 is less, so 10 stays in the max value. This value here, we ask, is it greater? The answer is no, it's less, so 10 stays in the max value. This guy here is in the fill slot because each run through this one, the next time it runs, this guy will be in the fill slot. Next time, whatever's in here will be in the fill slot. This here is the fill slot, and the comparison is being made. Well, is 10 greater than 4? Yes, it is the answer. So yes or true. The only thing left to do is to then swap their position. So 10 goes into this position where the 4 is. The 10 will go into there, and the 4 gets swapped to wherever the 10 is in the list, in which case it is in here. So you can see where the comparisons are being made. The max value there, we find the algorithm finds the max value in the list, and then once it gets to the end of the list, it compares whatever is in the max value with whatever is in the fill slot. And if it's greater than what's in the fill slot, then it swaps and puts it into that position there.
If you liked this video, give it a thumbs up and try out one of my other videos.